Hello everybody, welcome into another lesson. So today we are going to use congruent triangles to prove other things. Today's lesson will consist of nothing more than 6 proofs, but knowledge of congruent triangles is required for this. So for our first proof, we are given in this triangle that angle P is congruent to angle S, because you have triangles POQ and triangles ROS right here side by side connected to each other. Well, angle P is congruent to angle S. So why don't we go ahead and set up some congruency markers there to aid us in that case. And then O is the midpoint of PS. Well, if O is the midpoint of PS, that would mean that PO and SO are both congruent. So by the definition of midpoint, PO and SO are congruent. So we need to go from there. We need to take these two given statements and then prove that O is the midpoint of RQ. So let's go ahead and set up our columns here. All right. Alright, so I've built the columns now. So I would say our first step in this one is, well, list the given statements. Angle P is congruent to angle S, as well as the fact that O is the midpoint of PS. Of course, the reason for that statement is it was given to us. These two pieces of information were given to us. Where do we go from there? Well, if O is the midpoint of PS, that means it splits PO and SO into two congruent segments. So we can therefore say that PO is congruent to SO simply by the definition of midpoint. That would be for reason 2, would be the definition of midpoint. Okay, is there anything else? Well, if we look here, we got two vertical angles. Angle POQ and then angle SOR. Those are both vertical angles, right? And we know that vertical angles are congruent, so we can go ahead and mark these congruent in our diagram. So now we can actually go ahead and say for step 3 that angle POQ is congruent to angle SOR. Why? What's the reason? The reason is vertical angles are congruent. Now where do we go from here? Well, let's look at these two triangles here. Notice in each triangle you have an angle, a side, and an angle that are congruent to each other in both triangles. So that sounds to me like angle, side, angle postulate. So from here, we can actually prove that triangle POQ is congruent to triangle SOR. That's going to be by the angle, side, angle postulate. So we've proven that the triangles are congruent. There's just one more thing now. Well, there's two more things. Couldn't we argue, because ultimately we're trying to get to O as the midpoint of RQ, right? If we've now proven these two triangles are congruent, you notice that QO and RO are corresponding sides of each triangle, right? if we remember, corresponding parts of congruent triangles are congruent. So your next step is actually to say that QO is congruent to RO. And that would simply be by CP/CTC. Congruent parts of congruent triangles are congruent. And then, if QO is congruent to RO, O's on the line segment, right? O's in the middle of segment RQ. We can therefore now say that O is the midpoint of RQ by the definition of midpoint. O is the midpoint of RQ. The reason for this is going to simply be the definition of midpoint. I'll go through this proof here real quick about what we just did. So, start out with your given information that angle P is congruent to angle S and that O is the midpoint of PS. That was given to you. Then based on given information here, if O is the midpoint of PS, that would have to mean that PO is congruent to SO by the definition of midpoint. From there, we could see that angle POQ and angle SOR are congruent because vertical angles are congruent. Next, based on what we had in our diagram and what we've done so far, we can actually determine that triangles POQ and triangle SOR are actually congruent to each other by the angle side angle postulate. Next, we can determine that QO is determined to RO by CP/CTC. Congruent parts of congruent triangles are congruent. And then if QO is congruent to RO, by the definition of midpoint, O is the midpoint of RQ. So that's how we got from here to here with those 6 steps. So some of these proofs will be a little bit longer than what we've done so far, but it's important that you see how these proofs work. Okay, what's the next one? Let's see, we have let's draw a little bit bigger here. There we go. We got 2 triangles. Points W, X, O. And then over here is going to be Y and Z. Okay, so we got our 2 triangles side by side connected. In this particular exercise, we are given, what we've been given here is that WO is congruent to ZO as well as XO is congruent to YO. What we're being asked to prove in this case is that angle W is congruent to angle Z. So we have been given, let's start there, that WO is congruent to ZO. So it would probably help in the diagram if we set up a couple congruency markers here, right? Okay, we also have that XO is congruent to YO. So let's set up some congruency markers here. And that's all we've been given so far. So once we've used our given information and reflected that in our diagram, let's go ahead now and draw up our columns. All right. Statements and reasons. Okay, so like we would with 90% of the proofs we do, start with your given information that WO is congruent to ZO, and then that XO is congruent to YO. That, of course, the reason is it was given to you. Alright, so we've spent all our given information. Is there any other information we can conclude? Well, looking at the diagram, wouldn't we see that angles WOX and angles ZOY are vertical angles? Those are vertical angles, are they not? And we know that vertical angles are congruent, so let's go ahead and place congruency markers for those angles. So that means here we can say that angle WOX is congruent to angle ZOY. That can be said by vertical angles are congruent. Alright, so far we now have some more pieces of additional information. From here, look at these two triangles. In each case, we have a side angle side congruent in each triangle. So the only logical conclusion now is that triangle WOX is congruent to triangle ZOY. The reason for that is the side angle side postulate. So our goal today is not just to stop at proving triangles congruent, we're trying to prove other things about these triangles. Okay, so we've gotten now that triangle WOX is congruent to triangle ZOY by the side angle side postulate. The only thing left to do is say angle W is congruent to angle Z by CPCTC. So angle W is congruent to angle Z. The reason for that is CPCTC. Corresponding parts of congruent triangles are congruent. So let's go through this proof again real quick. We were given that sides WO and ZO of these two triangles were congruent, as well as sides XO and YO were congruent. We listed that in our statements. That was given. From there, we were looking at the diagram, able to determine that angle WOX and angle ZOY are congruent to each other by the fact that vertical angles are congruent. And then we could next determine that triangle WOX is congruent to triangle ZOY because you have in each one a side angle and a side congruent to each other by the side angle side postulate. And then last but not least, angle W is congruent to angle Z by corresponding parts of congruent triangles are congruent. So that proof really wasn't that bad. That was a 4-step proof. That actually really wasn't that bad. Okay, should have 4 more. Let's see here. There we go. All right, there's our next one. We got A M, B, C, and D. Alright, so we have two triangles connected side by side, triangles ACM, and then triangles MDB. So what do they give us to start with? What are we even given? Well, let's start there. What are we given first? That M is the midpoint of line segment AB. We're given that. Oh, I forgot to number angles here. Yeah, that's kind of important if I would number angles. This one actually had angle numbers. 4 and 2. There we go. Alright. They also give us here that angle 1 is congruent to angle 2, and then that angle 3 is congruent to angle 4. We actually have a lot of given information. We have quite a bit of given information. But what do they want us to prove out of that? What are we to prove? We are to prove that line segments AC and BD are congruent to each other. So we next prove then that line segments AC and BD are congruent to each other. So let's go ahead and set up our two-column proof. I hope everyone can see that okay. Alright, good. I just want to make sure I'm not in the way of anyone trying to write this down or figure it out. That way, it's important you can see. So we got our statements, we got our reasons. Alright. Like you would anywhere else, start with your given information. So M is the midpoint of AB, which when we list this in the proof, ultimately that's going to mean that AM is congruent to MB by the definition of midpoint. So let's go ahead in our diagram, place a congruency marker at each of these. What else? Angle 1 is congruent to angle 2. Then angle 3 is congruent to angle 4. So we've put our congruency markers up. Okay, that's good. Now let's go ahead and proceed to the proof. So let's see, statement 1. M is the midpoint of AB. I would actually, this is one where you're going to use the given information in pieces. Even though the angles are given to us, we don't put all that in the first step. You're going to see why in a second. Of course, for statement 1, that M is the midpoint of AB, that was given. But what about midpoint? Well, that only means that AM is congruent to MB by the definition of midpoint. They would actually be congruent then. Now, once you've established that you have two congruent sides out of this whole midpoint thing, I would say your next step is to list the congruent angles that were given to you. So angle 1 is congruent to angle 2, and then we also have that angle 3 is congruent to angle 4. That again would end up being given information. So sometimes you'll split the given information up and you'll have it in a couple different steps instead. That you'll see like this, there's a time and a place for that. Okay. So far we've got that M is the midpoint of AB, that was given, which means by the definition of midpoint that AM is congruent to MB. And then we've established that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4 by given information. Where do we go from here? Well, I would say our next step is to prove these two triangles congruent. Each one has an angle, side, angle, side, angle that are congruent. So our next step is to say that triangle ACM is congruent to triangle BDM. They are congruent by the angle, side, angle postulate, or the ASA postulate, however you want to say it. So now we've actually been able to prove these two triangles congruent. Ultimately, they're asking to prove that AC is congruent to BD. And actually, that's our next step. Now that we've proven the triangle's congruent, we can now prove that AC is congruent to BD by the fact of CP/CTC. Corresponding parts of congruent triangles are congruent. So let's go through this proof again real quick here. Okay. Started with our given information. M is the midpoint of AB. That was given. Which by the definition of midpoint then, you can say that AM is congruent to MB. And then we take the other two pieces of given information, that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, which was given. From there, we were able to deduce that triangle ACM is congruent to triangle BDM by the fact of the angle, side, angle postulate. And then lastly, we can prove that AC is congruent to BD by CP/CTC. Corresponding parts of congruent triangles are congruent. Alright, we're halfway done with the lesson. Now we just got 3 more proofs. Okay, what's next? What's on the menu here? We're actually going to use the same two triangles here for the next 2 proofs, but we're going to do different things with them every time. So let's go ahead here, build our triangles. Alright, so we have our 2 triangles. We have ADM, EB. Okay, so we have 2 triangles side by side, ADM and MEB. So what have we been given for this particular one? What is the given information? They gave us that AD is parallel to ME. So AD is parallel to ME, which is going to be interesting in a second. We also have that MD is parallel to BE. And there's one more piece of given information. Also that M is the midpoint of AB. So we have all those pieces. Ultimately, what's our goal to prove? This exercise, we are to prove that MD is congruent to BE. So out of all this, we're going to prove that MD is congruent to BE. Okay, we'll do congruency markers in a second. I think for now, why don't we go ahead here, set up our columns. So let's go ahead and do just that. Set up your columns. We have statements on the left. We got some reasons on the right. Okay, so this might be a big one. I'm not going to lie to you. This might be a big one. We're going to take this one piece by piece. Start with the fact that AD is parallel to ME. So AD is parallel to ME. In fact, now that we've written that, why don't we put parallel markers on this? AD is parallel to ME, so we got that. All right, that of course was given to us. So just with the first given statement, where do we go from here? Where do we go from here? We can say, since we know that AD and BE are parallel, AD and ME are parallel, we know for a fact that AB acts as a transversal, right? AB is a transversal to these two parallel lines, which could only mean then that corresponding angles are congruent. So that's going to mean that angle A is congruent to angle EMB. So angle A would be congruent to angle EMB by the fact that corresponding angles are congruent. So angle A is congruent to angle EMB by the fact that you have two parallel lines cut by a transversal, then you have corresponding angles are congruent. So that's good. We've started out strong there. Now let's move on to the next piece of given information. Well, we have here that MD is parallel to BE. MD is parallel to BE. That's also given to us, so that was freely given. So now that we know that MD is parallel to BE, let's go ahead and set up some parallel markers on this also. We'll set up our parallel markers for those to demonstrate that. Now, if MD and BE are parallel, isn't it also true that line segment AB acts as a transversal? Which once again then you would have angles DMA and angle B being corresponding angles, which would be congruent. So we can, I don't want to write in red for this, I'm trying to keep that. I want to write in green. So the next statement we should have is that angle DMA is congruent to angle B by once again that corresponding angles are congruent. Alright, so good. And these triangles now, we've at least proven two congruent angles, haven't we? Now let's go on to the final piece of given information, that M is the midpoint of AB. So well, let's write that in our given. M is the midpoint of AB. That, of course, was given to us. That's going to be reason 5. Which, if we look at this diagram here, if M's the midpoint of AB, that means by the definition of midpoint that AM would be congruent to MB. So now we have two congruent sides in the triangle, do we not? So the next step here, immediate next step, is to say that AM is congruent to MB by the definition of midpoint. Now, I think from here, let's look at these two triangles. In each triangle, we have an angle, side, angle congruent to each other, do we not? I should have put two congruency markers here. There we go. We have an angle, side, angle of each triangle congruent to each other. I think from here, that's grounds to prove that these two triangles are congruent. So the next statement's going to be is that triangle ADM is congruent to triangle MEB by angle, side, angle. This one is by the angle, side, angle postulate. These two triangles are now congruent, which can mean that now that we've proven triangles congruent, we can actually indeed prove that MD is congruent to BE by the lovely CPCTC. Corresponding parts of congruent triangles are congruent. So MD is congruent to BE by CPCTC. So let's go through this proof again here. As you see, this was another good example of why you don't always want to use your given information all at once, because you're just going to make your life a lot harder that way. First, we started with the fact that AD is parallel to ME. That was given to us. And then if those two lines are parallel, we were able to deduce that angle A is congruent to angle EMB by the fact that corresponding angles are congruent. Next thing we use another piece of given information that MD is parallel to BE, which then, if MD is parallel to BE, we can deduce that angle DMA is congruent to angle B, also by corresponding angles are congruent. And then from here, we use the last piece of given information for statement 5, is that M is the midpoint of AB that was given, and which means by the definition of midpoint that AM is congruent to MB. From here, we were able to prove triangle ADM congruent to triangle MEB by the angle, side, angle postulate. And then last but not least, the ultimate proof that MD is congruent to BE by CPCTC, or corresponding parts of congruent triangles are congruent. So I know that one seemed a bit like a doozy, but that was an 8-stepper, and sometimes you're going to have that. And unfortunately, there's no way around a long proof sometimes. But you have to really list your steps out. You can't just jump from one thing to another. You have to show where you got it from when you're dealing with proofs. Good news is we're learning more theorems, so life is easier for us. A lot easier than it used to be. Alright, I'm going to erase these congruency markers because so far they have not been given to us yet, if at all. We're using the same triangles, believe it or not, for this one. We are going to, but we have to put different things on here if we get different stuff. We don't want to have the same information up that wasn't given to us. Alright, let's connect these gaps a little bit better. There we go. Alright, we got our triangles back in shape again. This particular one with these triangles, what do they give us? So they start out this time giving us that M is the midpoint of AB. So we've actually been given first that M is the midpoint of AB. They also give us that AD is congruent to ME. What else do they give us? They even give us that AD is parallel to ME. So what is our goal to prove in this particular one here? What are we going to prove with this? We have to prove that MD is parallel to BE. All right. So let me set up the columns again here. I'm going to make these nice and big because this is going to be yet another long proof. I hate to say it, but it's going to be. Statements to the left, and then reasons to the right. Okay, so now that we've got that set up, let's start with our first piece of given information. Take this one piece at a time. We have that M is the midpoint of AB, right? M is the midpoint of AB. The reason, it was given to us. So reason one, that's our given information. Which this is going to go to step 2 here. Since M is the midpoint of AB, that's going to mean that AM is congruent to MB. So let's go ahead and set up congruency markers here, right? And then let's go ahead and list this as statement 2, is that AM is congruent to MB by the definition of midpoint. Alright, so out of one piece of given information with these two triangles, we already have one pair of congruent sides. We're getting somewhere. Now, what's the next piece of given information that we have? We have that AD is congruent to ME. Step 3 is that AD is congruent to ME. In fact, in this one, you could actually even combine that AD is parallel to ME. You'll see why in a second we were able to combine these last two. Of course, the reasons here are that that was given to us. So based on the given, AD is congruent to ME. Okay, there's really not much more to say about that, just other than to mark them, right? But we're also given that AD is parallel to ME. So let's go ahead and set up our parallel markers. So set up your parallel markers. Okay. Now, big if AD is parallel to ME, doesn't AB act as a transversal? We can therefore argue that angle A is congruent to angle EMB by the fact that corresponding angles are congruent. So for step 4, we can say that angle A is congruent to angle EMB by the fact of reason for step 4 is that corresponding angles are congruent. Okay, so let's look at what we've got so far. we have a side, angle, and side of each triangle that are congruent. I think the only logical place to go from here is that triangle ADM. So triangle ADM is congruent to triangle MEB by the side angle side postulate. So the reason for these two triangles being congruent is the side angle side postulate. Alright, so that's great. We've proven that triangle ADM and triangle MEB are congruent by the side angle side postulate. Well, that helps, but how do we get to MD is parallel to BE? We could say that MD is congruent to BE because corresponding parts of congruent triangles are congruent, but that doesn't help us prove they're parallel. If we remember, what does help us prove lines are parallel ultimately are the angles. We can actually now say that angle DMA is congruent to angle B. Why is that? Since we've proven the triangle is congruent, we can say angle DMA is congruent to angle B by, you guessed it, CPCTC. Congruent parts of congruent triangles are congruent. So, in fact, I'm going to go ahead and mark these on the diagram here. It's going to aid us in the fact of determining parallel lines. So we got two corresponding angles are congruent, right? So if you have two lines cut by a transversal and corresponding angles are congruent, then the lines are parallel. So step 7, we can now finally prove that MD is parallel to BE. Why are they parallel? It's going to be because corresponding angles are congruent. So for the converse of the postulate and the postulate itself, you can abbreviate both in a proof as corresponding angles are congruent. Your teacher will most likely know what you mean. Most teachers don't want you to sit there and write out the whole entire theorem because that would just take too long to grade and read, and they'll know what you mean. So let's go through this proof again here. In this particular case, we'll start with what we're first given, that M is the midpoint of AB. That was given. Then by the definition of midpoint from this statement, we can conclude that AM is congruent to MB. Next, we use the last two pieces of given information, that AD is congruent to ME and AD is parallel to ME. Well, as far as AD congruent to ME, there's really not much more we can do with that. We just simply mark it in the diagram. But with AD being parallel to ME, there is something we can do with that. That allowed us to conclude that angle A is congruent to angle EMB by the fact that corresponding angles are congruent. Which then led us to conclude that triangle ADM is congruent to triangle MEB by the side angle side postulate. Which then would allow us to conclude that angle DMA is congruent to angle B by corresponding parts of congruent triangles are congruent. Which ultimately last, we can conclude that MD is parallel to BE by the fact that corresponding angles are congruent. So these are some very interesting proofs. These basically combine everything we've learned up to this point. And it's good to have lessons like this periodically to check your understanding, to assess where you're at. And if you are struggling with anything up to this point, there is no shame in that. I want you to know there's no shame in that. That's what my previous videos are for. They'll be there forever. They'll be there for free. So please feel free to check them out. And I have one more, and then we're done for the night. Okay. So we got two triangles here. P, Q, R, and S. So there's two triangles there. We have angles 1, 2, 3, and 4. Alright, so this is the last proof of the day, and then we're done with the lesson. What do they give us in this one? We have been given that PQ is congruent to PS. We've also been given that QR is congruent to SR. So QR is congruent to SR. There's more we're given. We're also given that angle 1 is congruent to angle 2. What we ultimately have to prove is that angle 3 is congruent to angle 4. Alright? So, we have here, again, I'll read this. I need the right color for the columns. We have that PQ is congruent to PS, QR is congruent to SR, and angle 1 is congruent to angle 2. Our ultimate goal is to prove that angle 3 is congruent to angle 4. Alright, this won't be so bad. Let's go ahead here and let's do our columns. Last proof, everyone. I know it's Friday evening, everyone's ready to not think about this, but this is still very important. So if you're with me so far, thank you for sticking with me. Okay, in this particular proof, and you'll see why in a minute, I think we can list at least the first two pieces of given information. So, now let's write in a different color for that. Step 1, statement 1, is that PQ is congruent to PS. And the fact that QR is congruent to SR. We're not going to talk about the angles, at least not yet. Of course, the reason here is this is given information. So now that we have the given information, why don't we mark that in our diagram? PQ is congruent to PS, so there's some markers. We have QR is congruent to SR, right? Well, I can tell you this. Let's look at this diagram before we even consider the angles. Both of these triangles share side PR, do they not? We know PR is obviously congruent to PR. That's going to simply be by the reflexive property. So PR is congruent to PR, therefore, by the reflexive property. So, it turns out we actually have three congruent sides. We have three congruent sides. We don't even need to consider angles 1 and 2. We really don't even need to consider them. We just have three congruent sides, which right away enables us to conclude that triangle PQR is congruent to triangle PSR. They're congruent by the side, side, side postulate, the SSS postulate. So triangle PQR is congruent to triangle PSR by the side, side, side postulate, which now means we can actually conclude angles 3 and 4 are congruent to each other by CP/CTC. So angle 3 is congruent to angle 4 by the fact that corresponding parts of congruent triangles are congruent. So that actually, what looked bad was only a 4-step proof. Yes, I'll go through this again here. First, let me start off by saying there will be some proofs, they'll give you more information than you need. They'll actually give you some information you don't need. So you got to be able to decipher that. And also sometimes they'll give you more information than you need because there's a couple ways to get to what you're trying to prove, but some ways are longer than others. So we went the route of PQ is congruent to PS and QR is congruent to SR. That was given. And then, by looking at the diagram, we can conclude PR is congruent to PR because both triangles share the same side there, and they're congruent to each other, the same side, by the reflexive property. Which right away at step 3, I can conclude triangle PQR is congruent to triangle PSR by the side-side-side postulate. And then last but not least, I can conclude angle 3 is congruent to angle 4 by the corresponding parts of congruent triangles are congruent, or CP/CTC. Which means I didn't even need to know about angles 1 and 2. That really wasn't relevant information for this. So that's it for this lesson. Next lesson, we're going to talk about the isosceles triangle theorems. So I hope everyone has a good night. Take care.